Today we're going to be using the heating and cooling curve to find how much energy is needed to change the temperature of a particular substance. Specifically, the problem that we're going to be answering is how much energy is needed to heat a 10.83 gram piece of aluminum from 25 degrees Celsius to 213 degrees Celsius. The first thing that we need to look at in this problem is the substance that we are trying to change the temperature of. And the substance is aluminum. According to our reference table, the melting point of aluminum is 660 degrees Celsius. So for this problem only, our melting point is going to be right here, and it's going to be 660 degrees Celsius. What that means for our problem is that the two temperatures, 25 degrees Celsius and 213 degrees Celsius, are going to lie somewhere below that 660 degrees Celsius mark, below our melting point. So our 2 points are going to be here and here, roughly. Now that we know and understand where we are on our heating and cooling curve, we can begin to answer the question. Because we are on this line of the heating and cooling curve where we are only changing temperature, and we're starting with a solid and ending with a solid, the equation that we're going to use is Q is equal to mCp delta T. The way that we know that we're using this equation is because it's on our blue line, and it's the equation that deals with changing temperature. Q equals mCp delta T. The variables in that equation are Q is equal to heat energy, so this is the substance that we are trying to find. Cp stands for specific heat capacity, and according to our reference table, the specific heat capacity of aluminum is 0.897, and the units are going to be joules per gram degree Celsius. Delta T stands for change in temperature, or the final temperature, TF, minus the initial temperature, TI. In this particular problem, our final temperature is 213 degrees Celsius, and our initial temperature is 25 degrees Celsius. Now that one other thing, M stands for mass, and the mass in this problem is 10.83 grams. So now that we've identified each of the variables in our equation, and we have read our question and understand what our question is asking for and what our question gives us, now we can plug this information into our equation. So we can say Q, which is the variable that we are trying to find, equals M, which is our mass, 10.83 grams, times our specific heat capacity, which is 0.897, and the unit here is joules per gram degree Celsius, times our change in temperature, which is the 213 minus the 25. So if we plug this information into our calculator, we have 213 minus 25, So our change in temperature for this problem is going to be 188 degrees Celsius. So we can say Q is equal to, again coming over here to our calculator, we can say 10.83 times 0.897 times 188, enter. And so the number that they give us on our calculator is 1,826.33. Now let's talk about our units. We have a gram on the top, cancels out with a gram on the bottom. A degree Celsius on the top cancels out with the degree Celsius on the bottom to leave us with the unit of joule. So joule would be our unit. If we go back to our problem to help us figure out the number of sig figs for our final answer, our mass has 4 significant figures. Our specific heat capacity, which was given to us, has 3 significant figures. Looking at our change in temperature, none of our numbers began with any decimals, so our final number does not have any decimals. And our final number, 188, has 3 significant figures. That's the number that we plugged into our equation. So our final answer should have 3 significant figures. So that means that our final answer should be 1,830 joules. So this is our answer.